Hello, this is Sujit. Welcome to Physics 2020. So today in this session we are going to discuss the numericals or problems in the topic of graphical analysis of motion. So in the previous section we have discussed the theory of graphs or the concepts of graphs. So what are the things we have discussed? What is slope of the curve? What is area under the curve? What is positive slope? What is negative slope? And the three types of graphs we have discussed, that is displacement versus time graph, velocity versus time graph, and acceleration versus time graph. So my dear students, always keep in mind the slope of the displacement time graph gives the velocity, the slope of the velocity time graph gives the acceleration, and the area under the velocity time graph gives the displacement. So once again I welcome you all to this problem section of graphical analysis of motion. Okay. So first problem. So consider a displacement time graph. Done. Five, 15, 25. Okay. So O, A, B, C. So find the velocity, find the velocity in the region OA, AB and BC. Okay, BC. So a displacement time graph is given like this. So we have to find the velocity in the region OA, AB and BC. So dear students, we know that the slope of the displacement time graph gives the velocity. So first I am considering the region, that is OA. Okay. So the slope formula, what is the formula? So velocity is nothing but the slope of the displacement time graph. So V is equal to, what is the formula? That is y2 minus y1 divided by x2 minus x1. Okay. So x1 y1 x2 y2, so OA. So here x1 y1, that is 0 comma 0, A, that is x1, that is x2, that is 5, then y2, that is 10. Okay, so that's equal to y2 minus y1, y2, that is 10 minus y1, that is 0, divided by x2, that is 5 minus 0. So 10 divided by 5, so that's equal to 2 meter per second. So that is the velocity in the region, that is OA. So next I am considering the region AB. So AB, what is the slope of this line, that is AB? So it is parallel to the time axis. It is parallel to the time axis. So slope is equal to 0. So therefore velocity is equal to 0. Okay. So next I am considering the region, that is BC. So velocity is equal to formula, that is y2 minus y1 divided by x2 minus x1. So x1 y1, x2 y2. So in this BC, okay, BC. So what is x1 y1? So x value, that is 15 comma y1, that is 10. in the region that is C x2 that is 25, y2 that is 0. So that's equal to 0 minus y1 that is 10 divided by x2 that is 25 minus x1 that is 15. So that's equal to minus 10 divided by 10, that's equal to minus 1 meter per second. So that is the velocity in the region. So in this line we get that is positive slope 2 meter per second. So when the line comes down, that is theta greater than 90 degrees. So in this line theta less than 90 degrees. So we get that is positive slope. So in this line that is theta greater than 90 degrees. So we get minus slope, that is minus velocity. Okay, minus velocity. Clear? So the second question. Identify the nature of motion from the following distance versus time graphs. Identify the nature of motion from the following distance versus time graph. So consider the following distance versus time graphs. So these are the following distance time graph. Okay, distance time graph. So we have to identify the nature of motion from these following graphs. So first graph, when you consider this graph at a time t1, the body is at a particular distance. Okay, at a time t2, the body is at the same distance. That means the body, as the time goes on, the body doesn't move from this from that position. That's why we can say that it is the graph of, that is, the body is at rest. Okay, body is at rest. So otherwise we can say that this line which is parallel to the horizontal axis. Okay, horizontal axis. That is, the slope of the graph is 0. That is tan theta 0. So the slope of the distance time graph gives the speed. Okay, so the slope is equal to 0, therefore the speed is equal to 0. That means the body is at rest. Okay, body is at rest. So first graph, that is, body is at rest. Body is at rest. Okay. 2. So this graph which inclined to the origin. Okay, origin. So it is a distance time graph. So the slope is equal to, so this graph represents the slope at every time, that is slope is constant. Okay, slope is constant. Slope is constant means that is speed is constant. That is the graph represents that is uniform motion. Okay, uniform motion, that is speed is constant, uniform motion. Okay, so as the time goes on, that is the slope doesn't change. Slope is always constant. Slope constant means the slope of the distance time graph gives the speed. Okay, speed. So the speed doesn't change, that is the constant speed. So that means it is a uniform motion. Okay, uniform motion. So the distance at time t is equal to 0, the distance covered by the body is 0. Okay, so inclined to the origin, the graph inclined to the origin means that is at time t is equal to 0, the distance traveled by the body is 0. Okay. So what about the third graph? So in this graph, so if you draw the tangent, that is if you draw the tangent, that is the slope that is increases. Okay, slope increases. So as the time goes on, the slope increases. So the slope of the distance time graph gives the speed. So since the slope increases means that is speed increases. Okay, speed increases. That means that is accelerated motion. Yes, accelerated motion. Accelerated motion. Okay. So what about the fourth one? So if you draw the tangent, that is okay, that is slope decreases. Okay, slope decreases as the time goes on, that is slope decreases. Slope decreases means that is speed decreases, that is decelerated motion. Decelerated motion. So as the time goes on, that is the slope of the curve decreases. Okay, slope of the curve decreases. That is the slope decreases means speed decreases. So it is a decelerated motion. Okay. So fifth question, it is a vertical line. So, okay, vertical line. That is the slope of the, so slope of this line is that is 90 degree. So tan 90, that is infinity. That is infinite speed. Okay, infinite speed. This graph represents that is infinite speed of the body. Okay, it is not possible. Okay, so not possible. Okay, not possible. Then sixth one, as the time goes on, the distance covered by the body decreases. So in a motion, the distance covered by the body never decreases. The displacement may decrease, but the distance covered by the body never decreases. So this graph, that is as time goes on, the distance covered by the body decreases. So the distance in a motion, as the time goes on, the distance always increases. Okay, see, it never decreases. So therefore the sixth graph, it is not possible. Not possible. Okay. Then seventh one. So for a particular instant of time, so the body covers two distances. Okay, two distances. So in a particular instant of time, that is the body, it shows, this graph shows that at a particular time, that is the body covers two distances. In a one-dimensional motion, that is, it is not possible. That is, the body never covers, does not cover two distances at a particular instant of time. So that's why it is also not possible. Not possible. Okay. So it shows, the graph shows at a particular instant of time, the body covers two distances. Okay. So two distances. So it is also not possible. Okay. So these are the distances. So first graph, that is the body is at rest. So identify the nature of motion from the following distance versus time graph. So we have to find what type of motion the body undergoes from this graph. So the first graph represents the body is at rest, that is the body doesn't move. The second one, that is a uniform motion. The body is uniform motion. That means constant speed. So as the third motion, that is, it is an accelerated motion. Fourth graph, that is it is decelerated motion. Fifth one, that is infinite speed, not possible. Sixth one, as the time increases, distance covered by the body decreases, it is also not possible. And the seventh one, that is at a particular instant of time, which the graph shows the body covers two distances, that is also not possible. Okay. So the next is third problem. So consider a tower. A boy standing at the top of the tower projects a ball vertically upwards. Okay. So the trajectory of the ball is given in the figure. So the path followed by the ball is shown in the figure. Okay. So we have to draw the displacement time graph for the trajectory of the ball, or for the motion of the ball. Okay, draw the displacement time graph. Draw one. Two, draw the velocity time graph. Velocity time graph for the motion of the ball. Okay, so ball is projected vertically upwards, so it reaches a particular displacement. Okay, so consider the motion of that is the point of projection as the origin. Okay, so the vertical upward direction as the positive axis and downward direction as a negative axis. Okay, negative x-axis. So this is the point of projection as origin. So upward motion in the positive axis and downward motion in the negative axis. Okay, so we have to draw the displacement time graph and draw the velocity time graph. Okay, so ball is projected vertically upwards. It goes a certain displacement, and when the velocity becomes 0, it comes down. It reaches the origin, and again it reaches the ground. Okay, so that is the trajectory of the path followed by the ball. So we have to draw first the velocity displacement time graph. Okay, displacement time graph. So at a time t, it reaches this maximum height. Okay, maximum height. So at time t, it reaches a height. Which is a height. So at a time, so when it reaches the that is original position, that is origin, that is the point of projection, that is time 2t. Okay, at time 2t, so the displacement becomes 0. That is, it comes to the original position. Okay, original position. At time t0, at time t0 it reaches the ground, that is the negative displacement. Okay, negative displacement. So it reaches, suppose this is the height of the tower, so height displacement in the negative direction. So height. Okay, so this is the displacement so traveled by the body. So when a ball is projected at a time t, it reaches a certain height in the upward direction t. So when time becomes 2t, that is the displacement becomes 0. That means the ball comes to the original position, and time t0, that is the ball from this mean position, that is the ball travels the negative displacement that is height, and it reaches the ground, So we have to find draw the displacement time graph. So when we draw the displacement time graph, so the slope of the graph will be like this, in such a way that so it correctly represents the velocity of motion, because the slope of the displacement time graph gives the velocity. Okay, so we have to consider the velocity of motion also, that is when a ball is projected with a certain velocity, and when at this point the velocity becomes 0 and it comes down, and it reaches the point, that is velocity becomes 0. So when it comes down, that is velocity is negative velocity. When the ball comes down, negative velocity. So negative velocity, that is velocity increases. So as the ball, when the ball is projected with the initial velocity u, as the ball goes upwards, the velocity decreases continuously. The velocity decreases. So at a particular, that is this height, that is the velocity becomes 0. So from that point it comes down, the ball comes down, that is the velocity is negative velocity that is increasing, increasing negative velocity. So throughout the motion, so from this point to this point, the velocity is negative velocity and it is increasing. So in such a manner only we have to draw the curve. Okay, so first when we draw the displacement time graph, the slope of the displacement curve, so it is like this. Okay, so from this point t, that is this point, so the velocity decreases, and at this point, that is the time t, this point the velocity becomes 0. So when you draw the tangent at this position, that is the horizontal to the time axis, so velocity becomes 0. So after that, from this point, that is the velocity is negative velocity. So throughout this point up to this point, the velocity is negative velocity and it increases. So the curve is like this. Curve is like this. Okay. So when you consider the slope of the curve, so slope decreases. Slope decreases. At this point the slope becomes 0. That means the velocity becomes 0. So from this point, that is the slope increases. Slope increases, but in the negative direction. So negative velocity. So up from this point to this point. It's a continuous curve. So the velocity is negative velocity. Negative velocity. So when we study the theory, that is, so the curve is like this, that is positive velocity, the velocity is positive decreasing, velocity is positive decreasing, okay, decreasing. So when the curve is like this, so that is velocity is negative increasing, velocity is negative increasing. So that is this portion of the curve. Okay. So next is draw the velocity time graph. Velocity time graph. Velocity time graph. So the ball is projected with a certain velocity, initial velocity. As the ball goes on, that is goes upwards, the velocity is continuously decreasing, okay, decreasing. At this point the velocity becomes 0, okay, 0. So when it comes down, that is negative velocity, okay, when the ball comes down, negative velocity. So at this point, that is time t, 2t, okay, 2t, this is the time t, this is the time 2t, and this is the time, that is when the ball reaches the ground, that time, that is t0, okay, t0. So from this point the velocity increases in the negative direction, that is negative velocity, it is increasing when the time t0 it reaches the ground. So the curve is like this. Curve is like this. Okay, so it has a certain velocity, initial velocity. So initial velocity. So when the time goes on, the velocity decreases. Okay, velocity decreases. At this point, that is the velocity becomes 0. What is this time? That is t. Okay, t. So after that, the velocity in the negative direction. Okay, negative velocity. So this is the velocity at time 2t. Okay, 2t, and this is the velocity, that is when the ball reaches the ground, that is t0. Okay, t0. Okay, so this is the velocity time graph. So the ball is projected with initial velocity, that is this velocity. So as the time goes on, the velocity decreases. Okay, velocity decreases when the time becomes t, that is the velocity becomes 0. Okay, so 0. So and after that the velocity is negative. When the ball comes down, it is a negative velocity. So negative velocity, the velocity is going in the negative direction. Okay, so negative. So at a time 2t. Okay, so it has the velocity that is as that of u. That is, this velocity is u. This also u. So the initial velocity. So at a time t0 it reaches the ground. Okay, ground. So this is the velocity time graph for the trajectory of the ball. So clear? So fourth problem. So the displacement time graph of two particles A and B. The displacement time graph of two particles A and B are straight lines which are inclined with the time axis of angle, it is A, that is 30 degree, that is 60 degree. So the displacement time graph of two particles A and B, so which inclined with the time axis with the angle that is 30 degree and 60 degree. So what is the ratio of, velocities of A and B. Okay, A and B. So option A 1:√3, option B root 3 is to 2. Option C, root 3 is to root 2. Option D, 1 is to 3. 1 is to 3. So the displacement time graph of two particles A and B is given, that is which are inclined with the time axis, that is 30 degree and 60 degree. Okay, 60 degree. So they are straight lines which are inclined with the time axis of angle 30 degree and 60 degree. So what is question is asked, that is you have to find what is the ratio of the velocities of A and B. So the option A, 1 is to root 3, B root 3 is to 2, C root 3 is to root 2, and option D, that is 1 is to 2. So velocity of A is equal to, that is tan theta. Okay, tan theta. So that's equal to, what is the angle of inclination, that is 30 degrees. So tan 30. So that's equal to 1 by root 3. So VB is equal to tan 60. Okay, tan 60. So that's equal to root 3. Okay, root 3. So we have to find, that is VA is to VB, that is the ratio of the velocities of A and B. So that's equal to 1 by root 3 divided by root 3. So that's equal to 1 by root 3 into 1 by root 3. So that's equal to 1 by 3. So that's nothing but 1 is to 3. So option D is the answer. Okay, option D is the answer. 1 is to 3. So fifth problem. So this is the displacement time graph. Displacement time graph. So 10, 5. So what is the, find the equivalent velocity time graph. Find the equivalent velocity time graph. ठीक है, velocity time graph. Option A, option A 2, option B 2, option C -2. Okay, option D it is velocity time graph. Okay, velocity time graph. So velocity time graph. Velocity time graph. Option D here. Okay, option D. -2. So this is a displacement time graph. What is its equivalent velocity time graph? So we know that the slope of the displacement time graph gives the velocity. Okay, velocity. So the slope of this curve, that is theta. Okay, theta greater than 90 degree. Okay, theta greater than 90 degree from this graph. So tan theta negative, ठीक है, tan theta negative, slope negative, velocity negative. Okay, velocity negative. So from this graph, so the slope of the graph is that is greater than 90 degree. So 90 degree means that is velocity negative. So here option that is velocity positive. So this is not the option. So velocity is positive here. So here also velocity is positive. So therefore these two options are not the answer. Okay. So when considering these two options, okay, these two options. This option velocity is negative, this option also velocity is negative. Okay, this graph shows velocity, negative velocity. So this or this. So from this displacement time graph, that is when you find the slope at each and every point, that is the slope is constant. Okay, slope is constant. So that means velocity is constant. Okay, velocity is constant. So negative, so each and every point the slope is constant. So straight line graph, okay, so the velocity is constant. So negative, constant. So which one? So this one, that is as time increases, velocity increases in the negative direction, velocity time. Okay, as time increases, that is velocity also increases. Here, that is the velocity is as time increases, that is the velocity is constant. Okay, velocity is constant. So therefore this is the answer. Okay, this is the answer. So it is how it is -2. So from that graph, that is slope is equal to slope of the displacement time graph gives the velocity. So velocity is equal to y2 minus y1 divided by x2 minus x1. Okay, so x1 y1, x1 y1, x2 y2. Okay, so this one x1 0, y1 that is 10. Okay, so this point x2 that is 5, y2 that is 0. So substitute the values. So y2 that is 0, 0 minus y1 that is 10. Okay, divided by x2 that is 5, 5 minus x1 that is 0. So that's equal to minus 10 divided by 5, that's equal to minus 2. So that's equal to minus 2. So that is the answer. Okay. Sixth problem. So consider a displacement time graph. Displacement time graph. Displacement time graph. So find the equivalent velocity time graph. Velocity time graph. Option A. Option B. Option C. Option D. Option D. So velocity time velocity time, velocity time. Velocity time. So the displacement time graph is given. Okay, displacement time graph is given. So we have to find the equivalent velocity time graph. Okay, velocity time graph. Velocity time graph. So when we discuss the theory, that is we have seen that is 4 types of graph, that is okay, 4 types of graph. This is velocity positive increasing, velocity positive decreasing. Okay, so this graph, that is velocity negative increasing, velocity negative decreasing. Okay, so we can divide our graph, that is displacement time graph, into that is 2 sections. So okay, 2 sections. So like this, the first part is like this. So this graph, okay, this part, okay, this part. So it is velocity positive. If the curve is like this, that is concave downwards, that is velocity positive decreasing, velocity positive decreasing. So first part. So at this part, that is the tangent. If you draw the tangent, that is it is horizontal to the, so it is parallel to the time axis. Okay, so the slope is equal to 0. Okay, slope is equal to 0, therefore velocity is equal to 0 at this part and this part. Okay, this part. So this is, so velocity negative increasing, velocity negative increasing. Now we compare the options. Okay, so total displacement time graph, so we convert, that is split into 3 portions. The first portion, so this portion and this portion. Okay, so this portion resembles this portion. Okay, so this portion we have seen, that is when we discuss the theory, we clearly discuss, that is velocity positive decreasing, velocity positive decreasing. So at this portion, if you draw the tangent, so in this point, so that is parallel to the time axis, so slope is equal to 0, therefore velocity is equal to 0. And this portion, so this portion resembles this graph. So this is velocity negative increasing, velocity negative increasing. Now you compare the options. So in this graph, so first velocity positive here, so velocity decreasing. Okay, velocity decreasing, clear. So velocity becomes 0. In this point, velocity becomes 0. Again the velocity positive, so therefore this is not the option. So in this option, velocity is 0 and velocity positive increasing, so this is not the option. So here initially the velocity is negative, so it is not the option. So when you come to this option, that is first velocity positive, okay, velocity positive decreasing. So when it comes down, that is velocity decreasing. So at a particular point, that is velocity becomes 0. So in this, that is velocity negative. So in this portion, from this point to this point, that is velocity velocity positive decreasing up to this point. Then this point, that is velocity becomes 0. Here velocity becomes 0. So after that in this portion, that is velocity is negative, that is as time goes on, that is velocity increasing. So velocity negative, so here this one, velocity negative increasing. So negative increasing. So this option is the answer. Clear? So velocity positive decreasing. So in this portion, velocity becomes 0. That is this point, velocity becomes 0. So in this portion, that is this portion, velocity negative. So negative, then increasing. So as time goes on, velocity increasing. Negative portion is increasing. So that is the answer. Clear? So the 7th problem. So a speed time graph of a particle's motion, which is moving in a fixed direction, is given. Okay. So speed time graph. Speed time graph. So speed time graph. Okay, speed time graph is given. Find the displacement find the distance traveled by the body. Distance traveled by the body between 0 and 10 second. 1. 2. Find the average speed of the body. Find the average speed of the body. Find the average speed of the body in the same interval. Body in 0 to 10 seconds. Okay, 10 seconds. So we know that the area under the speed time graphs gives the distance. Okay, so the distance traveled by the body is nothing but the area under the triangle, that is 0 to 10 seconds. So the area under the triangle OAB. So this area gives the distance traveled by the body between the time interval 0 to 10 seconds. So distance equal to area of the triangle, OAB. So that's equal to half into 10 into, that is height, that is 12. Okay, so 5 times, that's equal to 60 meter. Okay, 60 meter. That is the distance traveled by the body in the time interval 0 to 10 seconds. The second one, find the average speed of the body in the same time interval 0 to 10 seconds. So average speed is equal to distance covered by the body, that is total distance divided by total time. Okay, total time. Total distance covered by the body divided by total time. So that's equal to total distance covered by, that is 60. What is the time? That is 10. So 0, 0 cancel. That's equal to 6 meter per second. So that is the average speed of the body. Clear? So velocity as speed time graph is given. So we have to find the distance traveled by the body between the time interval 0 to 10 seconds. So the speed of the area under the speed time graph gives the speed. Okay, so the area under the speed time graph gives the distance. So this is the speed time graph. So area under that's nothing but the area of the triangle. Okay, area of the triangle OAB. So that's equal to half into 10 into, that is 12. Okay, that is equal to 60 meter. So average speed is equal to, we know the formula, that is total distance covered by the body divided by total time. So that is equal to 60 divided by, so 60 meter divided by total time, that is 10. So that's equal to 6 meter per second. So 8th problem. A car which is at rest, okay, that is u is equal to 0, okay, which is at rest, accelerated with a constant acceleration a, okay, constant acceleration a, and it reaches a maximum velocity, that is Vm, okay, constant velocity Vm. So after that, in time t1, so after that it decelerated. Okay, decelerated with the same acceleration, that is constant acceleration a, and after time t2, so the car becomes rest, that is v is equal to 0. So find suppose the distance covered by the car, okay, distance covered by the car is capital L, okay, capital L. Find the time of journey. Find the total time of journey. So a car which is at rest, that is u is equal to 0, is accelerated with a constant acceleration a. After time t1, it reaches a maximum velocity. Vm. Okay, so after that it is decelerated with the constant acceleration a, and after time t2 it comes to rest. Okay, rest. So we have to suppose capital L is the total distance traveled by the car. We have to find the total time of journey. Okay. So I am going to draw a graph. So using graphical method we are going to find the total time of journey. Okay, so I am going to draw the velocity time graph for the journey of the car. Velocity time graph. Okay. So velocity time graph. So at a time t is equal to 0, the car starts from rest, that is velocity is equal to 0. Okay, velocity to constant acceleration. Okay, constant acceleration. So after time t1, after time t1, so it reaches a maximum velocity Vm, that is Vm. Okay, so after that it decelerates and decelerates. After time t2 it comes to rest, that is velocity 0. So that is the displacement time graph, sorry, velocity time graph of the car. Okay, a car starts from rest, that is initial velocity 0, at time t is equal to 0, initial velocity is 0. So after that it accelerates with a constant acceleration after time t1 it reaches a maximum velocity Vm. Okay, so after that, from that point it starts to decelerate with a constant acceleration, that is a. After time t2 it comes to rest. Okay, so we have to find the total time of journey. So we know that the area under the velocity time graph gives the displacement. Okay, displacement. So area under this triangle, so area under this velocity time graph is nothing but the area under this triangle. Okay, triangle. Okay, so the distance traveled by the car, so distance is equal to area of the triangle, that is OAB. Okay, that is area of the triangle, OAB. So that's equal to half into base, that is t1 plus t2 into, that is height, that is Vm. Okay, Vm. So in the question it is given the total distance traveled by the car is capital L. So L is equal to half into V1 plus V2 into Vm. Okay, so we have to find, sorry, not V1 plus V2, that is T1 plus T2. So we have to find the total time of journey. It is nothing but T1 plus T2. Okay, T1 plus T2. So T1 plus T2 is equal to 2L divided by Vm. So that is the total time of journey of the car. Okay, T1 plus T2 is equal to 2L by Vm. Clear? So the next is the 9th problem. Consider a velocity time graph. Okay, consider a velocity time graph. A train starts from rest and it is accelerated at a time that is 10 seconds. It reaches a constant velocity. Okay, constant velocity 30 meter per second. From 10 to 20 seconds it runs with the constant velocity, that is 30 meter per second, and after that it starts to decelerate. At a time t is equal to 32 seconds it comes to rest. So find the distance traveled by the train. Distance traveled by the train. Okay, find the distance traveled by the train. Option A 630 meter. Option B 620 meter. Option C 1200 meter. Option D 500 meter. Okay, a train starts from rest and it is accelerated through a constant acceleration After at time t is equal to 10 seconds, it reaches a constant velocity that is 30 meter per second. From 10 to 20 seconds, it runs with the constant velocity that is 30 meter per second, and after that it starts to decelerate. Okay, decelerate, and at the time t is equal to 32 seconds, it comes to rest. So we have to find the distance, the total distance traveled by the train. So the distance traveled by it's a velocity time graph. So the area under the velocity time graph gives the distance. So distance equal to area of OAE, that is the triangle. Okay, OAE, triangle OAE, plus area of the rectangle ABED. Okay, ABED, plus again the area of the triangle BCD. Okay, BCD. So that's equal to half into area of the triangle OAE, half into 0 to 10, that is 10 into height, that is 30, plus area of the rectangle 10 to 20, so 10 into 30. Okay, plus area of the triangle BCD, so half into 20 to 32, that is 12 into 30. Okay, so that's equal to 2, 5, so 150, plus 10 into 30, that is 300, plus 6 times, so plus 180. Okay, so 300, 180, 150, so 314, 5, 6, so 630 meter is the answer. 630 meter. So the next is 10th problem. Which of the following curve does not represent the motion in one dimension. The motion in one dimension. Option B. So velocity time graph. So which of the following curve does not represent the motion in one dimension? So in one dimensional motion, at a particular instant of time, the body has only one velocity. Okay. So in two-dimensional motion, that is the projectile motion, the body have two types of, at a particular instant of time, the body has two types of velocity. That is, the body undergoes two types of velocity. That is, one is the horizontal velocity, another one is the vertical velocity. Okay, the body undergoes in projectile motion. So in this next chapter, we will discuss projectile motion, that is motion in a plane, motion in two dimensions. So in this chapter, we are only concentrating on motion in one dimension. Okay, one dimension. That means the body at a particular instant of time, the body has only one velocity. The body undergoes only one velocity. So in projectile motion, the body undergoes two types of velocity, that is horizontal velocity and vertical velocity. Okay, vertical velocity. So when this curve, that is at each and every that is instant of time, the body has only one velocity. Okay, only one velocity. So here also the body has at a particular instant of time only one velocity. So in this curve also, that is at a particular instant of time, the body has only one velocity. So but this curve that is at a particular instant of time, okay, instant of time, the body has two velocity, okay, two velocity. It is not possible in one dimensional motion. So this is the answer. Which of the following does not represent? So this is the answer. Does not represent the motion in one dimension. So in one dimension, at a particular instant of time, the body has only one velocity. In projectile motion, in two-dimensional motion, the body undergoes horizontal velocity and vertical velocity. So in that, the body has two types of velocity. Okay, two types of velocity. So with this, I wind up this session. That is the problem section part 1 of, that is graphical analysis of motion. So we will meet with the second problem section of graphical motion. Stay tuned. Goodbye.